a problem from probability distribution and says that if f1 and f2 be two probability distribution function of two random variable, okay, probability distribution function of a random variable it is, so that their convex combination f, this is lambda f1 plus 1 minus lambda into f2, where 0 less lambda less 1 is also a probability distribution of some random variable. Okay, here it is given that f1 and f2 are the probability distribution of a random variable. We have to show their convex combination. This is the convex combination of f1 and f2, where 0 less lambda less 1. This is the condition of convex combination. This is also we have to show this is the probability distribution. Okay, to show f is a probability distribution, we must have to prove all the property or the main property of distribution function. We know that this is the definition of distribution function, and the main properties of distribution function, which are if x tends to minus infinity, then this is 0. If x tends to infinity, this is 1. If x tends to a plus, this is f of a plus 0. Okay, we know that because a plus 0, this is equal to f of a. Because we know that the probability distribution function is continuous from the right. Okay, and if x is continuous random variable, then the derivative of distribution function gives the PDF. Okay, where fx is be the PDF of x. We prove all the property one by one. If we write here limit x tends to x tends to infinity, capital F1x, this is obviously 1 using the property 2, and similarly limit x tends to infinity f2x, this is 1. Okay, also by using first property limit x tends to minus infinity f1x, this is 0, and limit x tends to minus infinity f2x, this is also 0. Now we take limit x tends to minus infinity fx, which is given by limit x tends to minus infinity, this is f1x into lambda plus 1 minus lambda into f2x. Okay, now this is lambda into limit x tends to minus infinity f1x plus 1 minus lambda into limit x tends to minus infinity f2x. And clearly if we put the value of this and this limit from here, we get lambda into 0 plus 1 minus lambda into 0. So this is 0, that is we write here this is 0, and this is the first property. And similarly if we take limit x tends to infinity and putting the value of this and this limit here and here, then we get limit x tends to infinity fx, this is lambda into 1 plus 1 minus lambda into 1. So this is obviously 1 because lambda and lambda cancel out. So second property is also hold. Now to show this property, we first write limit x tends to a plus 0, capital F1x, this is capital F1 a plus 0, this is F1a. And similarly limit x tends to a plus f2x, this is f2a plus 0, this is f2a. Now if we take limit x tends to a plus 0 fx, which is given by lambda into limit x tends to a plus 0, and the first limit is f1x plus 1 minus lambda into, this is the second limit, x tends to a plus 0 f2x. By putting the value of these two limits, we get lambda into f of f1a plus 1 minus lambda into f2a. Okay, and now if we put a in place of x, we get from here, this is f of a which is given by lambda f1a plus 1 minus lambda into f2a. Okay, this is f1a plus f2a. So we write this is f of a, and clearly this side is f of a plus 0. This is the right hand limit. So we say that at any point a, this function, that is the convex combination of f1 and f2, where f1 and f2 are the distribution function, then f is also continuous from the right. Okay. Also, if we differentiate, or if we first take the random variable, this is continuous. Then if we differentiate this term, we get f dash x, this is lambda into f1 dash x plus lambda 1 minus lambda into f2 dash x. Okay, and using this property, if we let that f1 dash x, this is f1x, and clearly this is greater or equal to 0 because it is PDF, and similarly f2 dash x, this is f2x, this is also greater or equal to 0, this is the PDF for all x belongs to minus infinity to infinity. This is the property of PDF. So we write that this is greater or equal to lambda plus 1 minus lambda into 0, we write here lambda into 0 plus 1 minus lambda into 0, this is greater or equal to 0 for all x belongs to minus infinity to infinity. So the same property is followed by capital F dash x. So we say that capital F dash x is a fx, and this is greater or equal to 0, that is fx may be or fx must be follow the property of PDF. Okay, so from all the condition, we say that the convex combination, this f is a CDF or probability distribution function. Okay, this is also known as CDF or cumulative distribution function. Very important but easy problem of probability distribution. Thank you for watching.